Okay, that's potassium. Okay, it's a positively charged ion. We call those cations. Okay, so it is more prevalent on the inside. So this right here, what I've drawn here is the inside of the axon. Okay. On the outside, you have more of that ion. What ion is that? Okay, sodium. It's really important that you know that potassium is more prevalent on the inside. Sodium is more prevalent on the outside. Okay. You also have some sodium on the inside. You have some potassium on the outside. But at rest, you have more potassium on the inside. Okay. Here's a way that one of my former students learned and remembered this. Okay, on the inside, and I think it works. On the inside, you have more potassium. Okay, IN is 2 letters. Potassium plus the charge is 2. Okay, this is the way he remembered on the outside. OUT is 3 letters. Na plus the charge is 3. Okay, it'll help you to remember. Use that mnemonic. Okay, so also on the inside you have OA negative, and what OA negative stands for is organic anions. An anion is a negatively charged ion. Okay, a cation is a positively charged ion. Okay, so that's what OA stands for, organic anions. And we have the negative because an anion has a negative charge. So organic anion is what that stands for. On the outside, you also have some chloride ions. Okay, but for this lecture, let's really just focus on the potassium and the sodium. I'm drawing the other ones in because in general, the inside has a more negative charge than the outside. By how much? By negative 70 millivolts. Okay, because there are quite a number of those organic anions inside. So that's what gives the inside a more negative charge by 70. Okay, so have any questions about that part? Okay, so this is what it looks like at rest. Okay, whenever the resting membrane potential, this is what's going on. Okay, so when these ions, they cross the membrane, okay, they can cross the membrane, and any time you change the resting membrane potential, anytime you change the resting membrane potential, these neurons can signal. So what changes the resting membrane potential? Some kind of stimulus. Some kind of stimulus is going to cause these ions to flow back and forth and change this. So in other words, it's not going to be at rest because this number is going to change. Anytime you have ions flowing back across the membrane, back and forth, you get a current. Okay? So in fact, it's an electrical current. So anytime they flow across, this is going to change. Okay, so there are 3 ways, kind of setting the stage. There are 3 ways in which ions can flow back and forth across the membrane. So I've drawn these little channels. That's what I've drawn in different colors. So from a previous lecture, what are these molecules that are embedded in the membrane?